Hey there, chickens! Welcome back. My name is Miss Danielson, and today we're looking at fraction addition and subtraction. We'll start with the very basics of parts of a fraction, comparing fractions, adding and subtracting fractions with or without common denominators, and then we'll move on to more advanced algebraic fractions. It could get a bit crazy, so I hope you're ready. Let's get started. Let's first start with the parts of a fraction. As you can see over here, the top number is called the numerator and the bottom number is called the denominator. You'll want to write that down. The numerator, which is the top value, tells us the number of parts we have. So in this example over here, we have 3 parts shaded in. 3 parts out of 8, that is. The denominator, that's the bottom number, tells us the number of parts it takes up to make one whole. So here there are 8 parts in one whole, and 3 of those parts are shaded in. A denominator could also be used to describe the size of each piece we have. So here each of these little pieces does not count as one. They are just one part out of 8 parts. So we would say the size of each of these pieces is 1/8 of a whole. We could also say that the denominator is the number of pieces that we cut or divide each value into. So this circle here was divided or cut into 8 equal-sized pieces. The numerator could also be considered the value that is being cut up or divided up. So we could say the fraction 3/8 is the same thing as the division 3 divided by 8. Now I hope you've heard the expression before, don't count your chickens before they've hatched. Well, I like to say, don't compare your fractions until you get a common denominator. I know what you're thinking. My way's a lot catchier, no? Anyway, so looking at 2 fractions, since we know that the denominator tells us the size of each piece, we should really pay attention to the denominator before we compare our numerators. So when you see that these 2 fractions have a numerator of 3 compared with a numerator of 4, don't automatically say that 4 is a higher number, so this is the bigger fraction. They look like they're almost exactly the same size. So let's compare the denominators first. An 1/8 is bigger than the denominator of a 1/10. So first we'll get a common denominator. To get a common denominator, find the lowest common multiple of the 2 denominators and make this your common denominator. So a multiple of 8, that is also a multiple of 10. The lowest common multiple of 8 and 10 is 40, because 8 times 5 is 40 and 10 times 4 is 40. But remember, when we get our common denominator, we need to multiply both the top and the bottom of the fraction by the same amount. So as we said, it was 8 times 5, so we must do both 3 times 5 over 8 times 5. And as we said, to get 40, we do 10 times 4. That would be 4 times 4 over 10 times 4. So both our denominators are 40 and our numerators are 15. 3 times 5 is 15 and 16 because 4 times 4 is 16. Now I can see clearly that with a common denominator of 40, my numerators can be compared and 16/40 is definitely bigger than 15/40. So I can use this inequality sign there to compare. Similarly, we can add fractions, but only once we've got that common denominator. We don't want to compare, add, or subtract the numerators without having a common denominator. So as we've already done, we've multiplied both the top and the bottom of the fraction to make our common denominator the lowest common multiple of 8 and 10 in this case. And then we can go ahead and add our numerators. 15/40 plus 16/40. The denominators are the same, so the answer will have that same denominator. We just need to add our numerators. 15 plus 16 over 40 is 31 over 40. Now that our chicken is hatched, it doesn't seem to be doing very much. I think we might be able to move on to slightly more challenging questions. Now, if that sounds a bit crazy to you, just stick with me. I promise you by the end of this, adding algebraic fractions will be easier than putting sneakers on a chicken. Now have a think about that. Putting sneakers on a chicken is actually pretty difficult to do, I would imagine. Let's give this a go. So long as the denominators are the same, we can simply add, subtract, or compare the numerators, whether they are numbers or variables. So the thing about algebraic fractions is the same as for any other type of fraction. We need to have common denominators. So here's an example. These are all algebraic fractions because they all involve letters, A, B, and C, but it's a nice easy one because we already have a common denominator of 7. And as we said before, if we have a common denominator, that will be the denominator for our answer. We just need to now add or subtract the numerators as it says. So A plus B minus C over 7. Now, as this is algebra, and these terms, A, B, and C, are not like terms, we can't actually take this any further, which is kind of a nice thing about algebra sometimes. Our answer can be left like this because it's already as simplified as we can possibly do. Here's another example. Again, these are algebraic fractions because they all involve a letter, but notice that the letters are all the same this time. All three of these fractions have a common denominator of W. So long as the denominators are the same, we can say that the answer will also have this as a denominator, and we just go ahead and add or subtract our numerators. So here we have 18 minus 12 plus 6 over W. This time, since our numerators are numbers, they can be grouped together, they can be calculated out. 18 minus 12 is 6, plus 6, that would be 12. So this is 12 over W. Hopefully that seems pretty simple and straightforward because I'm giving you common denominators here. Let's try one more example. List these fractions in order from smallest to biggest. Now that should be fairly simple if we have common denominators. And in most cases we do. These are all algebraic fractions and the denominators all involve the letter S. All of them, in fact, have a denominator of S except for this one. This one is 3S. Now, to get a common denominator, we look for the lowest common multiple. So since this is 3S, 3 times S, I could multiply all of the other fractions, both top and bottom, by 3. Or look at this carefully. I can simplify this fraction. I can divide both the top and the bottom by a common factor. 3. 18 divides by 3, and 3s divides by 3, giving us 6 over s. Now I've got 5 fractions. They are algebraic fractions, but they all have a common denominator of s. So we can go ahead and put them in order from smallest to biggest. That would start with, obviously, the negative one, negative 13 over s, then 2 over s, then 4 over s, then 6 over s, which was this 18 over 3s, and 7 over s. Simple. Let's go on to a slightly more challenging set of examples. Let's get our common denominators this time of these algebraic fractions. Think about your lowest common multiple. That might include both a number and a variable. In this case, I've got 3 algebraic fractions. However, the denominators are numbers, so we don't need to worry so much about the letters on the top. Let's just get the denominators the same. Lowest common multiple of the numbers 8, 3, and 4. Think of the 8's times tables, the 3's times tables, and the 4's times tables, and see what would your first match be. I'm thinking 8 times 3 makes 24, and 3 times 8 makes 24, and 4 times 6 makes 24. So 24 was my lowest common multiple, and remember, to get that common denominator, we need to multiply both the top of the fraction and the bottom of the fraction by the same amount. So I've got 3a plus 16a plus 6a over 24. The denominator does not change. We've got a common denominator for that reason. So let's just have a look at our numerators now. They are all like terms. They are all some number of the same variable. Let's just see how many a's would that be. That is 3 terms, but it is not 3a. The first term on its own is 3a. 3a plus 16a is 19a. Plus another 6a would be 25a. Hopefully that's pretty straightforward. We do know how to simplify expressions like this up top here, and we now know how to get a common denominator, and we know that that denominator does not change when we're just adding or subtracting fractions. Next example, this time we've got algebraic fractions, but the denominators have variables in them, and the denominators are not the same. So let's get a common denominator, and here it's a bit challenging because I need to think of the lowest common multiple of 3x, 5, and 12y. First, think about the numbers. What's the lowest common multiple of 3, 5, and 12? I'm thinking 3 times 20 makes 60, 5 times 12 makes 60, and 12 times 5 makes 60. But I also need to look at the letters. This first fraction here has got an x in the denominator. The last fraction has got a y in the denominator. So my lowest common multiple of these algebraic denominators should include both x and y. So this first fraction will need to be multiplied by a y because it's already got the x. This middle fraction will need to be multiplied by both x and y because it doesn't have either of them. And this last fraction will need to be multiplied by x. It's already got the y. So there we have it. 3x times 20y will give us 60xy. 5 times 12xy will give us 60xy. And 12y times 5x will give me 12 times 5 is 60xy. So our common denominator is 60xy. And notice I'm multiplying the numerators by the same algebraic expression that I've multiplied the denominators by. So I end up with 20y plus 24xy minus 30x. Now I've got a common denominator. The denominator did not change. All I needed to do was add or subtract the numerators as it says in the question. Now looking at those numerators, they are all algebraic terms. They are not like terms because they don't have the same variables. So we can't simplify that anymore. However, do look at your whole fraction as an answer. Can I simplify that fraction? Remember, to simplify a fraction, we look for a common factor that we could divide both the top and the bottom by. Look at all 3 terms on the top. Is there some number I could divide all 3 of those terms by? That I could also divide the bottom term by? I could divide both top and bottom by 2. 20 divided by 2, 24 divided by 2, 30 divided by 2, and 60 divided by 2. Hopefully we're getting the hang of this now, and chickens in running shoes is not seeming like quite such a crazy idea anymore. Let's try adding algebraic fractions with whole number terms now. Now, how can we add a fraction with a whole number term? You need to remember that whole numbers stay the same even if we divide them by 1. And fractions really are just the numerator divided by the denominator. So let's turn our whole numbers into fractions over 1. For example, a over 7 plus 11a. 11a is not a fraction, but we could write it as a fraction. 11a is the same thing as 11a divided by 1. So we can write this as a over 7 plus 11a over 1. Now we're still not quite ready to add those fractions because we don't have a common denominator. Don't count your chickens yet. So let's get that denominator the same. What's the lowest common multiple of 7 and 1? Hopefully this is obvious and clear, and it should be just as easy for adding any kind of whole number term. We can just multiply 1 by 7 to make it 7. So 11a times 7 over 1 times 7. That's going to be a over 7 plus 77a over 7. Now that we have a common denominator, we know that the denominator of our answer will be 7. but we'll add our numerators. A plus 77a. Be careful, they are like terms, but the a with no number out front means 1a. So 1a plus 77a is 78a over 7. Now looking at the numerator and the denominator, there is no common factor. I can't simplify this fraction. So there's my algebraic fraction, as simplified as it can be. Example 7, I've got an algebraic fraction subtracting an algebraic term, and the 4u is not a fraction, but we could make it a fraction. 4u divided by 1 still has that same value, so we can say 5u over 2v minus 4u over 1. Now let's get that common denominator. Even though the denominator is going to be an algebraic one with the letter v in it, it's very easy to match our denominators, because to get 2v as the denominator for our second fraction, we just need to multiply 1 by 2v. So we'll also multiply the 4u by 2v. Now if you don't remember to multiply two algebraic terms, we need to multiply number by number and letter by letter. 4u times 2v will be 4 times u is 8, and u times v, we'll just put them alphabetically, uv. Now that we have our common denominator, we know the denominator of our answer will be 2v, and we just need to subtract our numerators as it says in the question. So 5u minus 8uv over 2v. Now since 5u and 8uv are not like terms, they don't have all the same variables in them, we can't simplify. We could see if we can simplify the fraction. Look at the terms on the top. Is there any common factor that you could divide them both by, that you could also divide the bottom by? You might be thinking 5u and 8uv could both be divided by u, but looking on the denominator, 2v could not be divided by u. So that is our simplified algebraic fraction answer. We can't do any more, so we leave it like that. Now, hopefully this isn't seeming so crazy for you anymore. Let's go on and try some practice. Let's go through the questions first, then I'll give you a chance to hit pause, work out your answers, and we'll take them up in a minute. For questions 1 to 6, you need to get a common denominator and then add or subtract your fractions as it says in the question, and simplify as much as possible. Got a little bit more challenging ones on questions 7 and 9 because we're adding or subtracting a whole number term. Again, remember how we deal with that. Turn your whole number terms into fractions over 1 and then match your denominators. Questions 10, 11, and 12 may look a bit more challenging, but let's get crazy here. Give it a go. Match your denominators by multiplying both top and bottom by the same value, and then go ahead and add your numerators as it says in the question. Go ahead and hit pause now. Copy the questions. Work through your answers showing you're working, and hit play when you're ready to take up the answers. I hope you had a chance to hit pause, because here come your answers. For question 1, our common denominator should be 20. And then adding our numerators. For question 2, our common denominator should be 40. Then adding our numerators, 34x over 40, which could still be simplified, dividing both top and bottom by 2. Question 3, the common denominator is 63. Question 4, the common denominator is 40x, which could also be simplified. Question 5, the common denominator is 12y, so that gives 5x over 12y. Question 6, our common denominator, we just need to multiply the second fraction by 2 top and bottom. Question 7, your common denominator will be 5x, giving negative 17 over 5x. Make sure you have the right sign. Question 8, our common denominator should be 20x. So that gives us negative 4 over 20x, which could also be simplified. Question 9, our common denominator would have to be 7. That gives 79x over 7. Question 10, our common denominator should be simple. It's just 12, 3 times 4, 4 times 3. And you'll need to multiply out a bracket. So we'll do 3 times x plus 1 here, 3x plus 3. So that simplifies to 7x plus 3 over 12. If that hint has just helped you to go through question 11 and 12, feel free to hit pause now and try that. Question 11, the common denominator is 6. So multiplying the first fraction top and bottom by 3 and the second fraction top and bottom by 2. With that common denominator of 6, our numerator becomes 8x plus 9 over 6. And question 12, our common denominator will be 12. And adding our numerators, we get 7x. Note that the negative 12 plus the positive 12 cancels out, so it's just 7x over 12. Hopefully you realize that just by knowing the basics about fractions, you can apply them to all sorts of fraction questions, including algebraic fractions, even when there may be more than one term in the numerator and a need for expanding brackets. So we're combining a lot of different skills here. So I hope you found this lesson interesting and a helpful reminder for you. Please let me know down in the comments section if you had any problems with that so I can help clarify any doubts. Also let me know if you need any additional lessons on either simplifying algebraic expressions, expanding brackets, lowest common multiple, because I'm sure I can refer you to several other lessons that might be helpful. Until next time, keep practicing and don't be afraid to try new things. It may look crazy, it may be difficult, you might make mistakes, but you also might learn something new and have an awesome time while doing it.